And we will, after the presentation, continue with Q&A. Good morning, everybody, and Mr. Nagel, thank you very much for your presentation of the operational sector. Mr. Vogelsang, you have asked a very important question, and Mr. Nagel wanted to conclude after 20 minutes, but it took him much longer, and now I only have 20 minutes. Well, this is the task we received from CESAR. It is measuring the noise emissions from RNP-RF in leg approaches. So we were comparing RNP-XLS, comparing the curved and the straight-in approach. The second part of the task was finding a difference of the noise emissions with regard to different glide slopes between 3 degrees and 3.2 degrees. And this is something which is only possible at the northwest runway here in Frankfurt. The second part of the test flights was conducted by Honeywell, and at the forefront of the tests of the demos, we said we need at least 10 approaches for measuring, for analysis. Unfortunately, we could not do it. We had 9 test flights, but we had very precise information. When it comes to the RNP-to XLS approaches, we were using the northwest approach with 70 to 75% of the cases. This is the wind type, and we were working with the Airbus A380, Boeing 747, and Airbus 319. These planes were complying with the regulations, with the preconditions, and we had measuring devices on the northwest runway, as I said, with the west wind conditions. So if you have such a task measuring the noise emissions, you have to think of positioning the measuring points properly. We determined some test conditions in the forefront, and we said we have specific measuring locations which do already exist. This is measuring station 42 in Neu-Isenburg. Then we have measuring station 01, which is here. And we said along the trajectory, along the flight route, we will have similar measuring stations which are parallel to the flight path and the runway threshold. Measuring station 42, this is where the planes are already in the final approach. We don't need a second measuring point. And when it comes to this corresponding measuring point, station 1, we created 87, which became operational at the beginning of June only, which means the A380 could not be measured here. And then we had 2 mobile measuring points, the 86 for the ALS approach and the 88 for the RNP approach. Then we have here the measuring point at the runway northwest. We have measuring point 44, which has already been used before. If you take a look at this definition here for analyzing the noise emissions, you have to take the dampening, the absorption effects into account. You have to deduct them from this equation. And this is the formula, that's how it is being calculated, defined in ISO 9613/2. And these calculations depend on the frequency because there are different dampening or absorption factors which have to be taken into account. They depend on the frequency. Then you have the directivity factor. The directivity factor depends on the location of the measuring points, and we focused on the maximum peak level, and we said the directory factor is the same in both approach procedures. And the target was to find out what the delta is, what the difference is between both approach procedures, which means this directory factor can be put at equal, and therefore it does not have any influence on the delta. So the major effects, the major absorption effects can be seen by the geometric spreading, which does not depend on any frequency, which is only determined by the distance between the plane and the position where the noise can be heard. And this is measured in meter, and then you have the air absorption. What else comes into play? You have humidity, you have temperature. On top, for example, you can see the atmospheric condition, you have temperature and the atmospheric humidity. This is what we tested with the A380. Here at the bottom, you can see the compared approaches with the ALS approach. We had 180 ILS flights, which were used to compare it to RNP approaches. And due to the fact that everything depends on the frequency, we said, okay, let's pick out some flights. Why doesn't it work here? We will pick out a few flights from this huge group. We will take the flights which comply with the same conditions like the RNP-to XLS approaches. After having done that, we came to the following conclusion. Due to the fact that we always have the same distance between the measuring locations, we do not necessarily need to calculate the absorption, because we have learned that there is no major influence of this on the noise emissions. Let's come to the results. This is the result for the A380. As I already said, we could not use measuring station 87 and 01, but we could see that on the other measuring locations we could see a higher noise emission, which is 1 dB higher than measured on the reference point 86 when it comes to ILS approaches. Then here, measuring point 42, this is the final approach, we had a higher noise emission amounting to only 0.4 decibel more. So that's not a major change. If you have a deviation of something which is up to 0.5%, then it's non-significant. The only size we are focusing on is the following. You know that there are some streaming sounds, and they are, of course, very decisive when it comes to flight noise. Flow dynamics can be heard. The surround flow around the airplane is something which needs to be measured as well. But if you take at the average difference of ground speed compared to the differences we have in noise emission, you can see here that on measuring point 88, there is no major difference in ground speed, even if we have a higher noise emission. And on measuring point 42, the average speed was slightly lower. And if you take a look at the spread, you will see it here. On the y-axis, these are the maximum emission levels. This is the ground speed on the x-axis, and this is the RNP-to XLS approach. These are the straight-in approaches, and you will see the difference immediately. Here we have 140 dB. This is the emission level. Please keep that in mind. So we have much more here, many more events which were higher than 140 dB. And in ILS, we only had once such a high value. So it's not the ground speed which can explain the higher noise emissions. This is what we learned. We believe that the higher noise emission comes from curved approaches with the respective configuration of individual planes. This is what we learned as a conclusion. Here we have a measuring point which is just before the turn. These are the planes which were on the straight track, still on the straight track, but then initiated the curve. And there are not many which deviated from that track, started with the curve flight a little bit earlier, which means those who had the deviation here belong to the group of the noise emission planes, creating higher noise emission. Now let's continue with the Boeing 748. I think it was on the 23rd of June when we had the first measuring flights. We had the new mobile measuring point, 87. You can see it here in the middle. Then measuring point 88. We had higher noise emissions than in measuring point 86. It is 0.5 decibel higher. And at the final, we had a slightly lower noise level, which means the noise emissions were decreasing. And the noise emissions are not influenced by the approach procedure. But what we did see is a higher noise emission in the turn just before the final approach was initiated. We have a higher noise emission by 2 dB. And if you take a look at the average ground speed, you will see that they were flying slower than in the ILS approach. And if we go back to that slide, you will see a similar scenario. Here you can see the emission levels on the x-axis. You can see speed. And if you're flying very slow, between 80 and 90, this is the range here, then you will see the ILS approaches. You will see that they're all below 140 dB. Whereas when it comes to the RNP-to XLS approaches, we have emission levels which are much higher than 140 dB. So, once again, if it's not the ground speed which can explain the major influence on the noise emissions, then it must be the plane configuration, the thrust which is being used. And we have learned, especially in a turn, you have to take much more noise into account. And in that project, we gained an overview of volumes, and when it comes to the 747, we learned that it can be up to 2 dB. How many slides do I still have? Maybe that one is not that exciting. This is the A319 with a runway 25. It's the northwest runway. You can see that we have a lower emission, lower by 1.1 dB, and the ground speed is also slightly lower compared to the ILS approach. Now you can see the difference between the RF leg approach and ILS. You can see that there is no major difference. These are the emission levels. These are the emission levels, which means we're talking here about 0.75 dB, so that's not much, and the average difference between the ground speed amounted only to 0.9 meters per second. We measured the ground speed very accurately in order to get precise information about the emission. So we measured on the ground, we measured in the air, and here you can see that we have a deviation on the measuring point itself. We had a maximum peak which was exceeded by 0.8 dB. Let me summarize my presentation. If you take the RNP to XLS approaches, then you will see that there are differences in noise emission. And Mr. Vogelsang, you have already mentioned it. When it comes to the curved approach, we're talking about a difference of 2 dB. And if you keep in mind the results I've presented to you, you will see that speed makes the difference. Speed is one factor which leads to differences in noise emission, especially if you compare straight and curved flights. But as soon as you come into the turn, you can no longer focus on speed alone. Here it is the thrust and the plane configuration which is responsible for the noise emission. Mr. Nagel has already talked about some recommendations we would like to give. We believe that turning or flying curves over residential areas should be avoided, which means we have to reconsider our flight paths in and around Frankfurt. And if you want to calculate flight contours and noise contours, you have to keep in mind that every turn brings about higher noise emissions. The emission levels were calculated on the basis of ILS, but now we have to adapt them to RNP to XLS. And here you can see noise emissions with regard to the glide path. We could not see any difference when it comes to 3.2 or 3.0 degrees, which means we do not have any higher noise emissions. And the lower value on the emission side amounted to 0.8 dB as already explained. And this brings me already to the end of my presentation, and now I'm happy to take your questions. Thank you very much, Mrs. Goldmann. Well, we have 20 seconds for Q&A, but okay, I don't want to be so strict. I will allow 3 questions. Mrs. Goldmann, thank you very much for your presentation. Your presentation is underlining everything which was mentioned yesterday. All the measures we are discussing at the moment are good, but not helpful. Helpful means that they will lead to a drastic noise reduction for residents in the airport region. But still, they are important, and this brings me to Mr. Da Silva's presentation. There are 5 pillars. One is being discussed intensively, but all the others, The other 4 remaining pillars still need to be analyzed and discussed thoroughly, because only then we will have a reduced noise situation. The curved approach has been discussed for many years, and in 2010 it was proposed as a potential measure, but we're still testing it. It's not something we're using on a regular basis, and whether it will really bring relief to the residents is still an open issue. So I'd say we have to discuss at the regional level the bundling over residential areas and focusing on specific times, and therefore it is of utmost importance to focus on all 5 pillars which were presented by Mr. da Silva yesterday. We have 2 more questions. Thomas Meder, thank you very much, Mr. Lanz, for giving me the floor. I have a question on slide number 11. If I remember correctly, we will see some flight paths. I think it was the previous one. You can see here in the curved approach, just before we have the final approach, you can see 2 main lines. How comes that we see 2 lines here? It's not 1 ideal line, it's 2. And I'm quite astonished that we have these 2 parallel lines. I thought that more accuracy is possible. So what is it? You're talking about this area here? These are not 2 flight paths. This is simply a deviation. You only had the 747, but this is a deviation which has a different reason. And when it comes to the accuracy of the flight path, then we were talking about 1 nautic mile, and within that nautic mile, you still can have such a deviation like this one here. So all in all, it is still precise enough to measure the noise emissions, and we can see higher noise emission levels. I did not mention it before, but Mr. Nagel, maybe you could briefly say a few words what RNP-1 and RNP-03 mean when it comes to accuracy. RNP-1, this was represented with the red line. We're talking about a flexibility, a scope of 1 nautical mile. And you have to comply with it in 95% of the cases. Then we come to the next step, 0.3, and in 90% of the cases this was complied with, which means we have more than half of the planes which were deviating to the left or the right of that track. But think of an A380 with a weight of several hundred of tons. This is quite difficult to stick to that accuracy which is required. Okay, then I'm not asking for further questions. Thank you very much, Mrs. Goldmann, Mr. Nagel.